Okay, I am on page 10 of our geometry packet. This will be the last page. Yep. This is kind of just like a review of everything we've done so far, just to kind of refresh your memories. Number one, it says solve the missing side using the Pythagorean theorem. It tells us in the directions, but also I know to use that because when it is a right triangle and you're only missing the third side, you can always use the Pythagorean theorem. Now, when you use the Pythagorean theorem, remember that C has to be the hypotenuse. That's your longest side, or the side across from your right angle, which would be x in this case. So x has to go in for c squared. Then 5 and 3 are your a and b. It doesn't matter the order because you're adding them. 5 squared plus 3 squared is the same as doing 3 squared plus 5 squared. Doesn't matter the order. So that would give us 25 plus 9 equals x squared. And then first I would go ahead and do 25 plus 9, and you get 34 equals x squared. But remember, this is not solved yet because I have this squared. I have to take the square root now of both sides. So let's see, that's going to give me a decimal, and I can just round to the nearest tenth. The square root of 34 is 5.8. Okay, the second one, find the missing side. So again, we're missing this side right here. This says 37 degrees. I know it's hard to see, but you should have the packet in front of you. And this side says 11. Now I have to use SOHCAHTOA this time. I cannot use Pythagorean because I don't have two sides and I'm just missing the third. I'm actually missing two sides. And this side in particular is what they want us to solve for because that's where x is. So I have to use SOHCAHTOA. So when you use SOHCAHTOA, circle the angle they give you, which is 37, and I label my three sides. Across from the right angle is my hypotenuse. And then, looking at my 37, if I drew an arrow, the CA here would be the opposite side. I don't need that though, because nothing is labeled on it. And then the third side is the adjacent side, which would be 11 in this case. So I'm only looking at A and H because those are the two sides of the triangle that are labeled with something. This side has nothing on it. So I got to figure out this A and H match up with sine, cosine, or tangent. Well, it would match up with cosine because cosine is A and H. So I'm going to use cosine. And the angle always goes in parentheses, 37. And it goes in the order that's written, A over H, so 11 over X. Now, before we can put this in our calculator on Desmos, if you remember when I taught this, if x is on the bottom, you have to put it in as 11 divided by cosine of 37. This is how you have to type it into Desmos. So I'm going to head and get rid of this stuff, and I'm going to do 11 divided by cosine of 37. Now remember, I need to go over to the wrench on the far right and make sure that word degrees is highlighted. And I get 13.8 if I round it. So x equals 13.8. That's the missing side. Remember that down here under functions, we have that sine, cosine, and tangent with negative ones on it. We only use that when we're solving for a missing angle. In this case, we were looking for a missing side, so I could just keep it as a normal cosine. So there's my x. Okay, these word problems, again, I know it's kind of hard to see. I'll read it out loud, but also you have the packet online for you to refer to. The word problems, the easiest way is to actually draw out the picture and the triangle, okay? They are the hardest to do. And again, drawing it out would be the easiest. It says a monument stands on level ground. I'll have this be my monument. The angle of the elevator to the top of the monument taken at a point 400 feet away is 32 degrees. So I know that's kind of a lot in that sense, but when it says 400 feet away, it's saying from on the ground, 400 feet away is the monument. So that's where 405 is going to go. And it says the angle of elevation, not elevator. My apologies. That says elevation. The angle of elevation to the top of the monument. Okay, so here's something we need to talk about. Elevation is on the ground. It's kind of the opposite of what you think. So it says angle of elevation is 32 degrees. So on the ground, inside my triangle, I'm putting 32 degrees because it's going to the top of the monument. Now, a lot of mistakes students make is they'll put 32 like on the side of your triangle. Again, it's an angle, so it has to go inside your triangle. This is where my right angle is going to go. So the 32 is either going to go here or here. Well, again, elevation's the opposite. It's going to go on the ground. And then it says find the height of the monument. Well, here's my monument, so this is where I'm going to put X. Okay, there's my triangle. Again, the hardest part is setting it up. I know that is very difficult. So I'm going to have to use SOHCAHTOA to solve for X, because I'm missing two sides. I can't use Pythagorean. So I'm going to label my three sides. So circle the 32. The side opposite of that would be O, so X is O. 405 would be A, because the side across in the right angle, this would be the hypotenuse, but I don't need that because nothing's written on it. So I'm looking at O and A. Now that matches up with tangent. So I'm going to use tangent to solve. Tangent of 32 equals, it's O and then A, so X over 405. Now, before I put this in the Desmos, this one's a little different because up here X was on the bottom. This case, X is on the top, so all you have to do is multiply that 405 and you get X equals 405 times tangent of 32. And that's exactly what you type into Desmos. So I'm going to type in the Desmos 405 times tangent of 32. And I get 253.1, and we'll say feet, because again, we're talking about the height of the building. Okay, let's try another word problem, our last one. A boy flying a kite lets out 150 feet of string. Okay, so here's this boy flying the kite. In the kite string, it says is 150. It says it makes an angle of 64 degrees with the ground. So here's the ground down here. 64 degrees, has to go inside your triangle. How high is the kite above the ground? There goes my X. Again, I know drawing the triangle, that's the hardest part. The string of the kite is 150 feet long. It wants me to figure out how high the kite is above the ground, so that's where I put X. This angle, it says it's on the ground. So inside my triangle, it has to go on the ground. So that's where 64 degrees is going. So to use SOHCAHTOA again, circle 64. I do have my hypotenuse this time, it's 150, and they give me the opposite side as X. They don't give me the adjacent, there's nothing labeled there. So they give me O and H. Well, that would match up with sine, because sine is O and H. So sine of 64 equals O and then H, so X over 150. Again, X is on the top this time, just like this example. So we need to multiply 150 on both sides to get X by itself first before we put it into Desmos. So this is what I'm going to put into Desmos. I'm going to put in 150 times sine of 64. And I get 134.8, and again we'll say feet because we're talking about how high the kite is above the ground. That's probably the hardest part of this packet are the word problems. Again, drawing out the picture, even attempting to draw the picture helps. But if you have any questions, just let me know.